So we're using the same circuit that we used to calculate the total resistance to calculate the voltage drop across each resistor. So as we already gone over, to find the voltage across a resistor, we just know it's a simple Ohm's law calculation. So in this case, we know that to experimentally find the voltage across each resistor, we know that it's just going to be a simple Ohm's law calculation. To find the total current through this circuit, we will need to find the total resistance and divide it by the total voltage applied to the circuit. So again, we can see that R2 is in parallel with R3. And since R2 equals R3, we know that the R total equals R2 divided by 2. So the equivalent resistance of R2 and R3 would be 0.75 k ohms, which is in series with the 1.5 k. So the total resistance of the entire combination of resistances is 2.25 k ohms. So now we go back to the equation we derived from Ohm's law to find the total current, which is total voltage over total resistance. The 9 volts divided by will give us 4 milliamps. Now, since we know that the current, this current generated from the 9-volt battery will flow into this, the first resistor R1, we can use that to find the voltage across it, which is 4 milliamps times 1.5 k, which is 6 volts. The same thing with the voltage across V2 and V3. We know that the combination of resistances in parallel will give us 0.75 k ohms multiplied by the total current, which is 4 milliamps, will give us 3 volts. You can also notice that the total voltage, 9 volts, equals the voltage drop across R1 plus the voltage drop across R2 in parallel with R3. If you were measuring this in a real life application with the digital multimeter, you will have to break the circuit and place the probes across the circuit so that the current will flow through the ammeter built inside the digital multimeter. Do not measure the current in a circuit in parallel. So, in other words, your DMM has an ammeter built inside of it. So, in order for it to read the current, you would need for the current generated from this 9-volt source to flow through the digital multimeter and then back through the circuit. And you should get the same value as we calculated.